All right, so you know how we do things here. We take the stuff you send us, and we really get into it.
Yeah, deep dive.
Exactly. And this time, it looks like we're going deep on Salesforce Marketing Cloud forms.
Forms, huh? Sounds riveting.
Oh, it is. Especially with the material you guys sent over. This article from Martech Notes by Marcel Simonis. He doesn't hold back, says a lot of what's out there about marketing cloud forms is just flat out wrong.
Oh, strong words. I'm intrigued.
Me too. And that's exactly why we're doing this. This deep dive is all about getting it right, making those marketing cloud forms secure and efficient.
And I bet avoiding some common pitfalls along the way.
You got it. So, let's just jump right in, okay? Marcel kicks things off by talking about this basic single-page form submission, the if it works, don't touch it kind of deal.
Yeah, I've seen that mentality, but where's the danger in that?
Well, he argues it can really open you up to problems. The way the data gets sent, that's the core weakness, right?
Okay, and he uses this example with AMP script.
Right, that if request parameter submit and request parameter email, the insert decline, what's actually happening there?
So for anyone who isn't super familiar with Marketing Cloud, AMP script is a scripting language. You use it to personalize things, handle data, stuff like that. In this example, the script is checking for two things: a parameter named submit and another one called email. If it gets both of those, it tries to add that email address to a data extension, which is basically like a database table in Marketing Cloud where you keep all your data.
Okay, that makes sense, but I'm guessing the problem is it doesn't really care how it gets those parameters.
Exactly, and that's a huge security risk because this basic setup uses a get T request to send the data.
GT requests. Remind me again why those are bad news.
All right, so picture this. You fill out a form, right? And when you use the GAT method, all that info you just typed in, it gets tacked onto the end of the website address right there in the URL for everyone to see.
Oh, so anyone could just grab that link, mess with the parameters, and bam, they're dumping junk into your data extension without even touching your actual form.
Exactly. It's like leaving the back door wide open. Plus, you have that whole issue with the duplicate submissions.
Oh yeah, hitting refresh and accidentally submitting the same thing twice. Yeah.
Right. That happens because with this single page setup, everything is happening on the same page. So you hit refresh, your browser might just resend that form data, and boom, another duplicate entry in your data extension.
Talk about a headache. So what's the next step up? Marcel mentions multi-page form submission as a partial fix. What's that all about?
Okay, so instead of one page doing everything, you have two pages. One for the form itself, and another one that handles all the data processing. This helps with that refresh issue, because once you submit the form and land on the thank you page, refreshing that second page won't resubmit the data.
Okay, that makes sense, but why is it only a partial fix?
Well, because while it solves the refresh problem, it doesn't address the core vulnerability of not checking how that request is being made. Someone could still bypass the entire form by going directly to that second page, that processing page, and just adding those parameters to the URL.
You mean like yourdomain.com form-processor.email and more junk at example.com. That easy.
Yep, that easy. So even if you have fancy validation and bot detection on your form, someone could just sidestep all that and go straight for your data.
Okay, so clearly we need a better way. Let's talk about Marcel's recommended approach, verifying the HTTP request type. What's the magic here?
The key is using server-side JavaScript, SSJS for short. It allows you to check if the request coming to your processing page is a POS2 request or a GET2 request. And when you submit a web form the normal way, by clicking that submit button, it typically uses POST to send the data behind the scenes.
So by checking for a POST request specifically, you're essentially blocking anyone trying to sneak in through the URL with a GT request.
Exactly. It's like having a bouncer at the door, only letting in the requests that came through the proper channels. And he gives a whole code example for this. Want to break it down?
Absolutely. Let's do it.
Yeah.
So first up, he's getting the HTTP request method. What's going on in those first few lines of SSJS?
Okay, so lines 1 to 3 are like setting up the tools. Platform.load core 1.1.1. That's loading some essential stuff that Marketing Cloud provides for your server-side code. But the important bit is variable set value at request platform.request.method.
What's happening there?
This line uses a Marketing Cloud function called platform.request.method. It figures out what type of request was sent to the page, get ET or post, and then stores that information in a variable called @request.
So @request is like a container for that info.
You got it. And then comes line 7, the if @request, post then statement. This is the gatekeeper, the real hero of the story.
So?
Because this line is saying, Only run the code that comes after this then if the value in our at request container is post. So if it was a GET request, like someone trying to mess with the URL, this whole block of code just gets ignored.
Ah, so that's how it blocks those sneaky submissions. Clever. Okay, what happens next?
Next, he grabs the email address using request parameter email. Seems simple enough, but then he adds a check to see if the email field is even there.
Why bother with that if you already have validation on the form itself?
Great point. Client-side validation, like using JavaScript on the form, is great for catching errors quickly and giving the user feedback right away. But it can be bypassed. Someone could disable JavaScript in their browser or even craft a custom request that skips your form altogether. So having this server-side check to make sure there's actually an email address, it's like that extra layer of protection just in case.
So make sure you're not processing empty or bogus submissions.
Right.
Smart. Now let's talk about the try-catch block in SSJS. This is all about handling errors during data insertion.
Yep, that's right. Think of it like this. When you try to put data into a database, sometimes things can go wrong. Maybe there's a connection issue, or the database is acting up. Without this try-catch block, if that insert to function fails for whatever reason, the user might just see a generic 500 internal server error message.
Which isn't helpful for anyone, right?
Nope, not at all. It's bad for the user, and it doesn't give you any insight into what actually went wrong.
So within that catch block, lines 14, 17, he sets a variable called error to true, and then logs the specifics of the error to a separate data extension called lead form error log. Why not just show an error message to the person submitting the form?
Logging errors to a dedicated data extension is so much better for a few reasons. First, it gives you detailed records of what went wrong. You can see the exact error message, the time it happened, all that good stuff. This helps you troubleshoot problems and understand if there are any recurring issues with your form. Plus, it keeps all those technical details away from the user, which can be confusing and potentially risky.
Makes sense. So if that @error variable is set to true, meaning something went wrong, lines 18, 19 redirect the user to an error page. He mentions a Marketing Cloud quirk here. What's that about?
Yeah. Marketing Cloud has this weird limitation where you can't directly use the redirect function inside of a catch block in SSJS.
Really? Why is that?
Don't ask me. It's just one of those platform-specific things you got to work around. So instead of redirecting directly inside the catch, you set a flag, in this case the @error variable. Then after the catch block is done, you check that flag and redirect if needed.
Gotcha. It's like a two-step process. And if everything goes smoothly, lines 20, 21 send the user to a thank you page, letting them know their submission was successful. Now, on top of all that, he also includes some client-side JavaScript. What's that doing?
That JavaScript is for doing some basic email format validation right on the page before the data is even sent to the server. It checks to see if the email address looks valid. If not, it shows an error message right there on the form.
So it's like a first line of defense, preventing invalid submissions from even reaching the server.
Exactly. It's all about improving user experience and reducing unnecessary load on your system. Now, stepping back a bit, what are the main advantages of using this recommended method?
Okay, so Marcel points out a few big wins. First, no more submissions via those sneaky GDT requests. Second, no more accidental resubmissions when someone hits refresh. Third, you have validation happening on both ends. Client side for immediate feedback, and server side for that extra layer of security.
Right, and don't forget about the error handling. No more ugly 500 internal server error messages. This approach ensures a smoother experience for your users, even if something goes wrong behind the scenes.
And he even talks about some ways to make things even better in the future, like using the SSJS execution context type post. What's the deal with that?
That's a neat trick. Adding execution context type post to your SSJS tag basically tells Marketing Cloud, only run this code if it's a PUSG request. Otherwise, just ignore it. This means you can skip that if at request post, then check and make your code a bit cleaner.
So less code, same result. Nice. He also mentioned sprucing things up with some CSS and enhancing the server-side validation.
Yeah, using a CSS framework like Bootstrap can make those validation messages look a lot nicer and more user-friendly. And on the server side, you can give more specific feedback about which fields are wrong and even pre-populate the form with the info they already entered.
That's huge for user experience. Nobody wants to retype everything just because they miss one little thing.
Totally agree. And to round things out, he touches on some additional security measures, like using recap TCHA and restricting access to the page.
Recap TCHA, that's the I'm not a robot checkbox, right?
Yep. It's a pretty effective way to filter out those automated spam submissions. And then you can restrict page access using things like IP whitelisting or even a simple login.
Right, especially if you're dealing with sensitive data or have a specific audience.
Absolutely.
And before we wrap up, he mentions a free ebook for anyone wanting to dive even deeper into this stuff. Covers both Adobe and Salesforce marketing clouds. Says to keep an eye on your inbox, even the spam folder, after signing up.
Nice. Always good to have more resources.
So to sum it all up, if you're working with Salesforce Marketing Cloud Forms, prioritizing those POST requests and having rock-solid error handling are absolutely crucial. These aren't just minor tweaks, they're fundamental to keeping your data safe and ensuring a good experience for your users.
Couldn't have said it better myself. By moving past those basic and often vulnerable methods and really embracing these best practices, you can seriously reduce the risks associated with spam, bad data, and frustrated visitors.
And that brings us to our final thought for today. As marketing tech keeps evolving, what other seemingly basic web practices might be hiding unexpected vulnerabilities? It's worth taking a step back and thinking about the bigger picture of secure data handling in everything we do online. Thanks for joining us for this deep dive.